Okay. So good afternoon, ladies and gentlemen, and welcome to the first plenary event of the 70th International Astronautical Congress. And as per tradition, we kick off the IAC week with the highlight of the plenary program, the Heads of Agency Plenary. In our capacities as IAF incoming president and president respectively, Pascal Ehrenfreund and myself will be moderating today's plenary. This year's Heads of Agencies panel will focus on the same challenges and opportunities in a changing space environment. Indeed, in an era of great changes and evolution for the space sector, space agencies still have a major role to play in the shaping of the future of space and in leading coordinated efforts between government entities and commercial and private companies. At the IAF, we work in the hope that all the space actors can collaboratively work together for a space that is truly for the benefit of all. This year, as we said this morning, we are celebrating the 50th anniversary of an historic feat, the first moon landing. For those of you that could not join us this morning at the opening ceremony, the IAF has awarded the Apollo 11, who, with its most prestigious recognition, the IAF World Space Award. For quite some time now, we have realized that space endeavors, especially those focusing on space exploration, are more successful when undertook as a collective and international effort, and I am looking forward to hear what exciting plans and projects our eminent speakers will share with us. Before diving into the discussion, I would like to share with you some logistics. Towards the end of the session, we will be collecting questions from audience through the IAF app, so please download the app and follow the instruction on the screen to register for the panel and ask your questions. Without further ado, let me introduce you today's distinguished speakers, starting with our host, Jim Bridenstine, Administrator of the National Aeronautic and Space Administration, NASA.
Thank you.
Jim?
Thank you, Jean-Yves. I appreciate it.
Thank you.
So it's great to be here at the International Astronautical Congress. My name is Jim Bridenstine. I'm the NASA Administrator. And we have a big agenda going forward to the moon. I said it, Jan, I said forward. We're going forward to the moon. We're not going back to the moon. And of course, we can do it with international partners, and that's what we're here to celebrate today. In fact, the very first Artemis mission that we do, Artemis 1, is going to have international partners with us because it will have, as a part of it, the European Space Agency through the European Service Module, which will be attached to Orion, and ultimately go to the Gateway, where at the Gateway, eventually we will have a landing system that can go back and forth to the surface of the moon. So this is what we are building. We're building the Artemis generation. We're going forward to the moon. We're going sustainably to the moon. We're going with international partners. We're going with commercial partners. We're going to utilize the resources of the moon to learn how to live and work for long periods of time, namely the water ice, hundreds of millions of tons of water ice on the south pole of the moon. We're going to take this architecture that we're building, and we're going to go to Mars. The Gateway is international in nature. Thank you to Japan for stepping up to the plate. Japan has announced that they want to be a big part of the Gateway with an international habitation module, and we are very hopeful that the European Service, or the European Space Agency will be joining us on the Gateway as well. And I'm doing everything I can ahead of the ministerial next month to make sure that people understand the United States of America, we need international partners. We can all do more when we work together than any one of us can do if we go alone. So this is what we are trying to build. When we think about the Gateway, think of a reusable command module that will be in orbit around the moon for 15 years. Now, it has a 15-year design life. What does that mean? That means it could actually last a lot longer than 15 years. But the bottom line is, it is a reusable command module that will be international in nature. Now, when we talk about it having a 15-year design life, It's also maneuverable. It can go to the North Pole, it can go to the South Pole, it can go to the equatorial regions. We will have more access to more parts of the moon than ever before. It is also open architecture, and that's the key takeaway for all of our international partners that are here today. When I say it is an open architecture, the way we do environmental control and life support, the way we do avionics, the way we do docking, the way we do data and communication, all of these things are going to be open to the public, available online. Why does that matter? Because then nations out there that want to go to the surface of the moon but might not have the budget to go on their own, they can join in the architecture with their own landing systems. They could join in the architecture, in fact, with their own astrophysics missions to look into deep space. And the other thing that enables us to do is bring in commercial partners. Maybe there's a private company out there that wants to go to the moon. Maybe there's a private company that wants to go to the moon and have NASA as a customer, but a private company that wants to go get customers that are not NASA. They can make their own investments and incorporate what they are doing with the architecture that we're building around the moon that we call Gateway. The Gateway is an enabler. It's a critical enabler for international partners, for commercial partners, and the Gateway itself is international. Here's the big takeaway. We have now been living and working in space for almost 20 years. We're entering the 20th year very soon. What does that mean? 15 nations have been operating the International Space Station now for almost 20 years. We've had astronauts from 19 different nations. Most recently, we had a new astronaut from the United Arab Emirates, which was a great and monumental achievement. But we've also had experiments from 103 different countries on the International Space Station itself. Well, here's the thing. When we go to the moon, we want to take all of the partners on the International Space Station and we want to grow it. We have Sam here, who of course represents ISRO from the nation of India, the Indian Space Research Organization. That's another opportunity to bring new partners into this international collaboration, this coalition of nations as we go forward to the moon sustainably with international partners, with commercial partners, where we go to utilize the water ice on the south pole of the moon to learn how to live and work for long periods of time, and then ultimately take all of that knowledge and build the architecture in a way that we can eventually take it to Mars. That's what we're trying to do. And of course, we are thrilled to be here at the International Astronautical Congress with so many friends from around the world as we build this international architecture to achieve what none of us could do by ourselves. So thank you so much, and I look forward to answering any questions.
Okay. Thank you, Jim, for these very inspiring remarks. And I would like now to invite Jan Werner, Director General of the European Space Agency, to give his remarks.
Thank you very much, Jean-Yves. And ladies and gentlemen, what you see over here is a crystal ball. And the crystal ball should tell you what is the future. And we don't know the future, and therefore we are talking about at these days of 50 years of Apollo. And I'm very happy that we are celebrating the past, but at the same time we should prepare ourselves for the future, because the future is unknown. We should not just look for the future, but to prepare ourselves. And this is exactly what Jean-Yves is saying. We are, and also Jim mentioned it already, we are looking forward to Space 19+. This is the ministerial of ESA, where all the member states of ESA come together, and all the ministers of the member states, and then you have to convince them. I have to convince them. And if you would like to convince people who are not automatically, like you are, converted ones, you need a narrative. And the narrative of ESA is now 4 pillars. Pillar number 1 is science and exploration. Pillar number 2 is all the different applications from space, from Earth observation, navigation, telecommunication. Pillar number 3 is enabling and support, where we have the space transportation, technology development, etc. in it. And then we created a 4th pillar, which normally is our number 2, but just because of didactic reasons, I mentioned it as the last one. This is space safety. covering hazards in space, originated in space, and hazards and threats originated on the surface of the Earth. And therefore, what we are doing with this Space 19 Plus, we are looking ahead and would like to see what can we do. And of course, we are tackling global challenges. You know all the global challenges. I mentioned only a few. Climate change, energy, but also curiosity. Curiosity is a little bit of different type of challenge, but it's the strongest driver of humankind, and therefore we are also trying with our space activity to cover this challenge as well. And all of this comes together in Space 4.0. Space 4.0 is a very general term which includes all the changes which we are observing, different actors in space, more than 70 spacefaring nations. The industry have their own space missions. Universities have space missions. So it's a totally different world with also totally different activities compared to what happened 50 years ago. And therefore, using new technologies, using new space, using artificial intelligence and Internet of Things is something which is very important. But what is the role of the public agencies? Is it, as in this picture, there is a decision whether we do public or private? Is that really the right question? In ESA, we believe that this combination of both, that's a very important part. We still work on the traditional way of agency. So, for instance, IALOS, a mission, an Earth observation mission, which is measuring the speed of wind. This mission was developed totally by ESA itself, together with the industry, but as an ESA mission. It took us several years, a little bit more than several years, and even a little bit more than several years. So it was really long, because to have a UV laser in space is really very, very difficult. But we succeeded, and therefore this type of missions will also be in the future done by public entities. The second one is, I call it NEOSA, just one example of our missions. Public-private partnership with industry to develop new platforms, for instance, for telecommunication satellites. We did that, and afterwards industry was able to sell 9 of these telecommunication satellites. So it's a totally different role of ESA. It's a partner role. The third one is ADRIOS, just as an example again. ADRIOS, where we are looking for a service offer of industry for space debris removal and also space debris avoidance. So we ask industry to provide us a service. So again, a totally different role where we are buying a service. And the fourth one is where ESA is a broker for activities which might be done by other players worldwide. And we heard already about the gateway. Our part of the brokerage is the Moon Village, where we put together players from around the world in a multi-partner open concept. For Space 19 Plus, what we are now heading to, I had as a title, Inspiration, Competitiveness, and Responsibility. Inspiration, this is all the science and exploration field. We are looking to black holes, and we are measuring gravitational waves and put them together, the X-ray measurements and the gravitational forces. We are looking to low Earth orbit Moon and Mars together, always with international partners around the world. So we are trying to convince our member states also to go for Mars sample return, again with international partners. We are looking for the European service module, more modules than under production right now. Also the gateway, we believe that we can contribute to the gateway. And then in situ resource utilization is also a topic we are looking forward. All of these science and exploration fields are international. The competitiveness, just to give you an example, the PPP I mentioned already, but also to develop quantum technology for telecommunication is one of the topics we are looking forward to. Navigation and also new types of launchers, big and smaller ones. And finally, responsibility. Responsibility, I can tell you, is the most difficult part to convince ministers to pay for it, because it's not directly return of investment, it's more a societal activity. But looking to climate change, looking to space safety, I explained it to you, and safety and security applications, this is what we try to get the support from our member states. And all of this, again, under the headline, celebrate the past, but prepare for the future. Thank you.
Thank you. Thank you, Jan, for these stimulating remarks. And now I would like to invite Hiroshi Yamakawa to give his remarks for JAXA.
Well, it is a great honor for me to have this opportunity to speak today. And it is my great pleasure to witness the 70th anniversary of the International Astronautical Congress. The theme of this IAC, excuse me, the power of the past, the promise of the future. So I would like to take this opportunity to introduce the past, present, and the future of Japan's space exploration activities. Well, Japan has over 60-year history of space development, and we have also been conducting the planet exploration for a very long time. Going back to the past, in 1985, Japan operated the Halley's Comet exploration satellite Sakigake and Suisei on the very left of this slide to observe Halley's Comet through international cooperation. Second satellite from the left is called Hiten, which is the first Japanese explorer to the moon, which was launched in 1990. And Japan became the third country to successfully send a satellite to lunar orbit. Since 2003, we operated asteroid explorer Hayabusa 1, second from the right, and succeeded in collecting a sample from an asteroid Itokawa and bringing it back to the Earth in 2010. We also operated the cylindrographical and engineering explorer Kaguya in Japanese on the very right of the slide to obtain scientific data of the lunar origin and evolution and to develop the technology for the future lunar exploration. Today, we are operating the Venus Climate Orbiter, which is called Akatsuki, which is shown on the very left side of this slide, to unveil the mysteries of Venus with an emphasis on atmospheric dynamics. The middle one of this slide is the asteroid explorer Hayabusa 2, aimed at collecting a sample from an asteroid Ryugu. This Hayabusa 2 successfully touched down on the target asteroid Ryugu this year and will return to Earth in 2020. And we launched the Mercury Magnetospheric Orbiter, MMO, last year on the very right of the slide to perform a comprehensive study on Mercury as part of Bepi Colombo mission, which is the ESA-JAXA collaborative project. As all of you know, excuse me, international momentum for Moon and Mars exploration is rapidly growing. JAXA also would like to actively participate in this space exploration to expand area of human activity from low Earth orbit to the whole Earth-Moon system. A meeting, as already introduced by Jim, a meeting of Strategic Headquarters for National Space Policy, led by Prime Minister Abe, was held last Friday, and the government decided the policy on Japan's participation in international space exploration proposed by the United States, including the participation in the Gateway program. To conclude my talk, space exploration is the ultimate challenge of exploring new frontiers and can be accomplished by bringing together state-of-the-art technologies on the global scale. So JAXA would like to participate in this spectacular challenge for humankind, along with our international partners in this room and our industrial partners also in this room. We are ready to take the next giant leap. Thank you very much.
Thank you, Hiroshi, for this great presentation. And now we'd like to invite Sylvain Laporte from the Canadian Space Agency to give his remarks. Sylvain?
Well, good afternoon, everyone. It's a pleasure to have the opportunity to address you today. A lot has happened in Canada since the last IAC, and I do want to spend a few minutes talking about those changes because they kind of reflect where we're seeing space going in the future. So for one, we've released back in March of this year the Canadian Space Strategy. And what's important here is that this is not the strategy of the agency. It's not a Canadian Space Agency strategy. It's a national space strategy that, of course, involves the agency, but a whole lot of other players. So it speaks to a whole of government approach to space, but even further, because in this strategy we've included industry, we've included our scientists and our researchers. It's a strategy that requires all of us as different communities to come together to deliver on our space program. So we're very happy that the strategy was released because it also makes some very strong statements that Canada's space program, which can be sometimes known for our niche expertise in space robotics with Canadarm and our long-standing involvement in Earth observation data with our RadarSat satellites, is now much more balanced. So we're looking at doing quite a number of other things than those two pillars. Of course, we're going to continue to strengthen our pillars, but we're also going to diversify quite a bit. So we're quite happy with the fact that this strategy is balanced. And one of the strategic thrusts, of course, is our contribution to Gateway. Canada is the first, and we will repeat this very often, we were the first international partner to commit to the Gateway. Right? So we're very proud of that historical moment. And we're looking at contributing the next robotics capabilities, and it will mean another arm. So on shuttle, we had Canadarm1. On the ISS, we had Canadarm2. So on the Gateway, we're going to have Canadarm3. And every one of these, of course, is a major step forward in technology. Canadarm3, in order for it to be as autonomous as possible, will have state-of-the-art artificial intelligence to make sure that we can benefit from every moment that the arm is out there on Gateway. And as part of that announcement to our Canadian Lunar program, we also announced an accelerator program called LEAP, so Lunar Exploration Acceleration Program. So we put aside 150 million Canadian dollars to look at building demonstrations and technologies for on-surface and on-orbit technologies for the moon. So we have launched our program by going to industry and to scientists, asking them what would be the best investments possible for the country. And we're in that phase now where we're analyzing the results. So I'm anticipating that this will mean groundbreaking work for Canadian technology in the future. Our lunar program also gets us into a much more intense position with space health. We clearly see that investments in space health also means investments for illnesses and cures for illnesses back down on Earth. So we've dialed up our investments on space health. Canada's been on the ISS for 20 years, and for most of that 20 years, we've used our allocation of time and resources on space health. So we're going to not just continue that research, but dial it up and potentially get into other areas of interest for space medicine. Again, with a direct line of sight of taking whatever we build for keeping astronauts safe and healthy up in space, and a direct line of sight to bring that down to us on Earth. And we're also going to get back into food production. So all in all, from an exploration perspective, it's been really great for Canada. All right, so these are not my slides. If I was paying attention to the screens in front of me, I would have realized that.
That's going good.
There we go. Okay, that's the one I want. Can I just show you the previous slide? There you go. All right, Earth, Moon, Mars, right? So looking forward. Okay, I'm caught up. God, I hate that when that happens, right? Apologies for that. All right, so we talked about a new space strategy. It comes with a lot of opportunities, of course. For example, we just launched back in June at Vandenberg Air Force Base in the US, 3 new generation of Earth observation satellites in a constellation. So we've kept the theme of RadarSat. So this is the RadarSat Constellation mission, or RCM short. What is really good about RCM is that the data will be open, right? We're encouraging the downstream, we're encouraging researchers and entrepreneurs to use the data to build the applications and to do the necessary science. With RCM, we have data continuity from, well, I'll go technical on you here for a sec, for C-band type SAR data. So we've got pretty close to 24 years of data accumulated since RadarSat-1. So that allows scientists quite a bit of depth and range with respect to some of the science they're conducting for soil erosion, for example, and ice movements and whatnot. So when you have decades worth of data, your science becomes that much stronger. So we're going to continue down that path. And from a balance perspective, we're also getting into some interesting new stuff. For example, we have a new satellite that we're working on now, which is in quantum computing being hot, quantum key distribution. So being able as a nation to have secure communications is very critical to our security, our sovereignty, our safety. So our new satellite called KeySat is actually going to be looking at distributing the quantum keys from space. So on Earth, because of curvature issues and whatnot, I think we've achieved close to 200 kilometers of range for quantum key distribution. So we're looking at doing that from space and allow a whole lot more flexibility from a global perspective. So quite interesting work in some new innovative technologies. We're also going to get into monitoring and helping first responders in terms of fighting fires. So there's already quite a bit of space activity for fighting fires, but what we are looking at developing with our wildfire sat is looking at data to complement the data set that currently exists. And WildfireSat will be looking at combustion material and the gases being emanated from the fires to give us an idea of intensity and combustion capabilities, so that we're complementing the data sets by providing firefighters on the ground with an idea as to what is more combustible out there in terms of forest and wherever that fire is progressing, so that they can concentrate their efforts into those areas as opposed to areas where the combustion may not be as strong as where the fires are. So in terms of guiding principles, we have taken the opportunity, because we have a new space strategy, to look at doing business differently. So we are very much looking at encouraging our Canadian space industries. We're very much looking at encouraging our Canadian researchers as we go forward. We're looking at putting in place new novel and very innovative business models to make that happen, to be more responsive to the industrial commercial timeline, and to provide openness to markets, to Canadian industry. It goes without saying, I guess, particularly in this forum, that the primary guiding principle for our strategy is all about international collaboration. I mean, let's face it, here I am, a Canadian speaking to you. I'm a member of some of the great powers, great economic powers on this forum. Canada's economy doesn't really compare to the economies of these gentlemen, but we're here today. Right? And Canada is here today because we take international collaboration to the next level. So we rely entirely on international collaboration to be successful in space. And this is something we're looking at strengthening, continuing strengthening, and making sure that we remain one of the leaders in international collaboration as we go forward. Thank you very much.
Thank you, Sylvain, for these exciting remarks. And now I will ask Sergei for Roscosmos to make his presentation. Sergei.
Russia has a pretty long history of rocket development and sending satellites to space. First experiments with rockets we started in 1930s. But since that, first satellite was launched, first human was launched, and of course, one of the main area of our development is launch vehicles. And right now, Russia has very wide variety of launch vehicles that is capable to launch satellite, humans to space, probes to deep space. And we also started, everyone knows about Baikonur, the first place where we start to launch humans to space, but now we are building Cosmodrome Vostochny, another launch site on Russian territory, and we also sending Russian rockets from French Guiana. And this year we did several launches there, and we are going to make even more till end of the year. Of course, important part of space activities in Russia is Earth observation. We are sending different satellites, and we have constellation of satellites like Resource, Canopus, Meteor, Electra, and Condor, and all of them help us to improve our knowledge about Earth, about weather. We are launching communication navigation satellites, GLONASS, and it helps us to navigate and not only navigate but also have our life more reliable because we use these systems to send signals in case of emergency. And majority of cars in Russia now equipped with this system, and in case of emergency it automatically sends a signal in order to help people who have a trouble. Talking about low Earth orbit, of course, the biggest project we built together with all international community in the last decades is International Space Station. We celebrated first launch of first module of International Space Station last year, and next year we are going to celebrate the 20th anniversary of human presence in space. And this project still stays and is a high priority in Russian space program. We not only do this program as Russian program, but we also work with international partners, and as was already mentioned, that recently new country joined us with first cosmonaut from UAE. Talking about space station, initially space station was built only for 15 years, and these 15 years already expired for most of the modules that are flying in space, but station is built with pretty big margins, and right now we already agreed to fly up to 2024, and right now together with other partners we are looking at opportunity to extend station life even further to 2028 or even beyond. It will depend on our technical analysis. Talking about exploration, we start to use not only investigate, but we start to use low Earth orbit, but for deep space we still need to be in investigation phase. Russian moon program is still under development, but of course we are sure that this program is going to be done in cooperation with our partners, especially very positive example of cooperation on space station program will help us to cooperate in future. We are building new human-rated spacecraft that is capable to fly to moon, and I hope it is going to be another way to send humans and cargo not only on low Earth orbit but beyond toward gateway and provide capability to land humans on moon in the future. And what ISS showed us that in spite of very reliable system that is built every country, but in case of emergency it's very important to have redundant system, and that's what actually happening right now. After shuttle was grounded, Russia helped all our international partners to send humans to space, and we think that this kind of relation will help us in the future exploration program. We also continue to use automatic probe. Actually, our primary strategy for for moon investigation, we are going to start from robotic probes, and for many decades, scientists is arguing what is more important, human investigation or robotic investigation. But we think that most efficient way would be when we work together, humans and robot missions, and provide information gathered on robotic mission for human space flights. We also continue our science missions, and just this year, our observatory Radio Astron that was providing data for international science community for more than 8 years just complete their mission. But this year we send another satellite, International Scientific Laboratory Spectre RG, that you can see on this picture. And we did it together with our German partners. And in year 2023, we are going to send next laboratory Spectre UV. Talking about future and use space for the future, of course, we are coming to a digital age, and space system, space communication, space imagery can help us to fill the database that can be used to improve our life here on Earth. We can monitor forests, water resources. This system can help us with cartography and help monitoring ecological damage that can be made even by human activity. Another part of space age, digital age, is informatization and, of course, global communication. So again, in vast areas, it can be done only through orbital system and orbital communication, orbital observation system. So that's it for the presentation. I would be ready to answer your questions.
So thank you. Thank you, Sergey. And now, if Mr. Somannath can give us his remarks for ISRO.
Thank you, Anne, and thank you, Pascal, and all my panelists. And good afternoon, all of you. Coming to the recent achievements in space since our last IAC we met, it has been an exciting year in India, Indian Space Research Organization. The launcher program goes very strong, and we have the next 3 launches getting ready at our spaceport. Coming to the missions of the Chandrayaan-2, all of you are aware about the excitement that it created in India and also world over. We had an exciting mission of the communication satellites as well as remote sensing satellite. The Cartosat-2 series satellite is one of the highest resolution satellite we have launched recently. The navigation cluster, the IRNSS and the NAVIC system is now operational, and we are looking at popularizing it across the continent. One of the precursors to the human space flight was the pad abort test, the crew escape system demonstration, which we successfully conducted. The 4th stage of PSLV continued to be in the orbit as a space junk, and we thought of using it as an orbital platform, and we successfully used it as a platform in which we have power generation, control, and some of the experiments that can be supported on the platform using the telemetry, the navigation system, and the power which is on board. And in the coming missions, we will be converting it into a long-duration platform where many of the scientists can put their experiments alone with all the bus support provided by the 4th stage or the PSLV. We also are looking at the communication satellite expansion with the launch of GSAT-11, and also the SARC satellite, which is a sort of a cooperation amongst the South Asian countries in bringing about the use of space and also bringing collaboration among the community. Coming to the challenges that we face in our sector, in aerospace, in India, are many. The top one is, of course, is human capital, in which we would like to develop people who will be able to take this activity along. in different sectors, from scientists to engineers to technicians, who will be able to build and then realize more numbers. And we are working across India in institutions and higher institutions, so higher learning, generating collaborative programs, creating laboratories and space museum to attract young people and inspire them. In the industry sector, we have a big challenge. We have been operating on a very small scale, but suddenly we wanted to expand the number of launches and the satellite building. Our industry is unable to cope up with this demand. In India, we have the public sector undertakings as well as some private companies who is supporting us. Of course, they are very large in numbers, but none of them are aerospace industries like what we have in the United States. So aerospace activity continues to remain as a small segment of their work. One of our important challenges is to create an aerospace industrial ecosystem in our country so that we can produce more rockets and more satellites and also more applications. Coming to the application segment also, the government demand is on the high side, and we are unable to meet those demands in the form of building the satellites and launching them. And we are also having quite a bit of applications being developed on government's insistence, which demands new instruments and new devices to be built. The startup ecosystem in our country is also very good. Young people trying to build small rockets, and then they are proposing to build small satellite to capture the small satellite emerging market, and interested to work on this area. I'm really inspired to see some of the people who are created an industrial ecosystem in small scale to take up this challenge along, and we would like to promote and help them to take this activity along. Now coming to the vision and the plan for the future, our exploration continued to remain on a small scale till recently, and it has taken a big jump with the Chandrayaan-2 and the Mars Orbiter mission, and we have a big program coming up in the form of Aditya L1, the exploration to Moon, the ExoWorld study of exoplanets, and also the Gaganyaan, where we would like to have our Indian put in orbit using our own launch vehicle and spacecraft. So this is a big challenge in front of all of us. Now coming to the application segment, the demand from the governmental system as well as on the social segment continue to rise. On the government side, that we have a demand for the remote sensing data as well as for the communication backbone, which ISRO is providing for the country. We have also the natural resource planning and mapping activity, which requires continuous launches of many satellites. Our navigation satellite cluster, we need to be expanded to farther areas, and that we have plans to build additional satellites to increase its reach beyond the Indian peninsula. So this continue to remain as a very top priority area. On the social segment, the whole of ISRO's activity is focused on application of space to the common people, and we continue to support this activity through various departments and various ministries, where our present government has taken it on a very high pitch, and almost 80 departments have come up with ideas how to make use of the space activity. And it's a big load on ISRO to adapt to all those demands and then create the tools and systems and the ground equipments and the data handling creatures and the product development to reach it to these departments and finally make use of it. And finally, looking at the launchers and the industry partnership, we have already announced that our PSLV, which is our workhorse launcher, is now ready to be produced from industry as a total. And ISRO would like to hand over this activity to an industrial cluster, which we have already offered. We are also developing small satellite called SSLV, which is an on-demand satellite that we can launch in 1 or 2 days' time of preparation, very short demand type of satellite. And this launch vehicle is getting ready, and we have announced that this also will be into the industry's hands. So this is a strategy that we have developed in India that we try to develop using the core capability we have and then hand it over to industry to create that ecosystem. Thank you so much, and this is what I would like to present on my initial briefing. Thank you once again.
Okay. Thank you for this quite a comprehensive presentation, and I propose that we now dive into the questions. And so, Pascal, I hand over to you for the first question.
Yeah, thank you very much. We have heard really the great programs and portfolio of all the space agencies. And I think there was one topic which dominated politics and press this summer and actually the entire year, and that is climate change. And I would like to address the question to you, and I want to start with Jan. What are your agency's space activities dedicated to climate change monitoring? And how do you actually cooperate internationally on this matter, and how you foster innovation in the downstream sector? And in particular, ESA, as ESA General Director, you are actually speaking for 22 nations, yeah, in Europe, and you have a very successful downstream gateway where you co-fund many businesses. We would really be very interested to know more about it.
Yes, thank you very much, Pascal. Climate change and the action towards climate change has for us three dimensions. Number one is the observation. Looking from space, we can have more than 50 of the so-called climate variables we can observe only from space. Therefore, we can give first-hand information about all of this, about temperature rise, about the question of glacier melting, ozone, etc., etc. So this is number one, to give the information to politicians, to the decision makers about the situation as such. This is one thing. So second thing is to really to work also on possibilities to reduce the impact of humans to the climate change. I give you one example. This is air traffic management. Through space technology, you can minimize the pollution of airplanes during travel from A to B, and the same is possible also for cars. So far you have in cars GNSS, satellite navigation systems, where you can select the fastest road or the shortest road. But maybe in the future you can also select the greenest road. This would be also a possibility. So this is number two. And number three is that in ESA itself we try to reduce our impact. And that means, of course, ban of plastic and all of this. But also we believe that digital ESA is a way forward for a green ESA. So I propose to the member states also to go in this direction, also for Space 19+. So your question concerning downstream is a special action. As you mentioned correctly, we have 22 member states, and we have, I mentioned, the 4 pillars. And therefore we believe we have so many possible customers outside, or persons or individuals interested in the subject, and at the same time we have inside ESA so many different subjects we can deliver. There must be some interface, and we call it downstream gateway, or one space to the customer, meaning if you come from outside, you have a certain door, a certain gate where you can enter, and you will really get some direction where to go, to which department, to which directorate. So this is where I believe that downstream gateway can play an important role to cover all the different subjects internally and also the world outside, space and non-space sector.
Great. Thank you very much. Mr. Yamakawa, I would like to address more or less a similar question, in particular because also Japan is really a paragon in Earth observations.
Excuse me. Your question about the environment, right?
Yeah, climate change.
Excuse me. So Japan has launched already 2 satellites dedicated to environmental monitoring, and especially observing greenhouse gases. And the accuracy of the observation provided by our satellites already reached a sufficient level of to contribute to improve the transparency of the reports on greenhouse gas inventory, and that each country is obliged to publish under the Paris Agreement. And at the IPCC plenary held in Kyoto in May this year, the effectiveness of the satellite observation data was recognized for the first time in the IPCC guidelines for greenhouse gas inventories. So JAXA will continue to address global issues using satellite data and strive to make various types of satellite as part of our social infrastructure. So that is our current approach.
And how do you engage, actually, how do you engage the downstream sector? Do you have particular activities? How you are trying to also involve the non-space sector in creating new business model for Earth monitoring?
Well, so it's not limited to, I mean, the environment problem, but everything. Is that your question?
So the link to our non-space sector.
Okay. Well, right now JAXA is doing several programs related to a kind of development programs to invite non-space actors. And for example, we are doing collaborative research with companies. The companies are doing research for their business on Earth, and JAXA is doing our research for use in space. And that means we call it dual use technology. Usually dual use means useful both for civil space and security space. But what I call dual technology right now is the technology which can be used both in space and on the ground. So this kind of technology can be used for business on the ground. Then that will help the non-space actors to go into research or business using space technology. So that is one of the examples of our approach.
Thank you. Jim, climate change activities, and how do you cooperate internationally, and how do you actually also incorporate the commercial sector?
That's a great question. So the United States of America right now has the highest earth science budget that it has ever had in its history. And so we're very proud of that, and we want to make sure we're continuing to study the Earth and gather all the data that we can possibly gather, and in fact share it with the entire world for free. I think that's the key. The key is sharing the data when we receive the data. I would say that if you look at what we're doing right now with the Orbital Carbon Observatory 3, which is on the International Space Station, and when we talk about future missions, a mission we call GeoCarb, which is a geostationary satellite in geostationary orbit, that gives us dwell over the United States, looking specifically at the sources and sinks of carbon emissions. I think that is you mentioned, how do you get the commercial sector involved? I think that is a great model for how to do that. That mission, GeoCarb, like I said, it's in geostationary orbit. It is not a satellite itself, it's a payload. It's a payload that will attach to a commercial communication satellite. So by doing that, you reduce the cost for the launch, you reduce the cost for a satellite bus, the power and the propulsion, and all of the other things that go into a satellite, and instead, you're buying a payload that can basically ride share on a satellite for being able to collect more carbon dioxide, more carbon monoxide, more methane measurements in the atmosphere than ever before, and doing it by dwelling. In other words, we're going to see in real time if somebody who is producing energy, if there's a methane leak coming from the Earth, instantaneously we'll be able to see it. What does that mean? That means there is an alignment, because energy companies want that data. Why? Because they don't want to get fined by the EPA. So now there's an alignment between environmental organizations and energy companies that ultimately getting the data and sharing the data and making it available to prevent these greenhouse gases from continuing to leak. There's an alignment that I think is very positive. So right now, I would say we're working very hard on these things all the time, and I think that we have a bright future in continuing to make the right investments and sharing the knowledge with the world.
Sharing, thank you. Yeah, we continue with ISRO. Mr. Sommernath, you have already shown some interesting activities in your slides, but maybe you could elaborate a little bit also on the cooperation with companies and the downstream sector.
Coming to the companies, we have been discussing quite a bit with the industries for enhancing the activities in aerospace sector. If you look at the name of these companies that I have mentioned in my slide, they are huge companies. They are infrastructural companies with industries, their interest spread across various sectors. Coming back to the aerospace sector, it continues to remain as a small segment in India. This is something which we were trying to enhance. And we have been talking to many of those industries in Europe and America to look at the possibility of coming to India and then set up their own manufacturing and production hubs, which I am seeing very interesting examples of some of them taking great lead in coming and then establishing facilities in India. The production demand for our launchers are now on the increase, and this is a great opportunity for that as side. Coming to the core industries, what I mentioned is important, but there are a lot of ancillary industries, something like 300 industries supporting our program today. And we have a significant amount of indigenization, that is production within India, that is happening now. It's really interesting thing to see that the change that is happening, that's the profitability, the turnover really increasing in this segment, which is really a positive thing.
Okay, Sergey, any comments to the climate change and international activities concerning remote sensing and activation and activities for the downstream sector?
You already mentioned that one probably most important part of monitoring climate change is Earth observation, and of course most efficient way to increase our efficiency of the data would be data exchange. We are trying to increase frequency of observing the same place with the same condition, because if you see what happens in this specific area once in several months is probably not sufficient. But of course, especially for Russia, for big territories, we try to use this data to monitor wood fire, and the sooner you start to fight with this fire, the least damage you have for forest and for environment, because all this burning wood is not good not only for local territory, but it may have even global effect. So I think the same idea that if we each country, each program has own data set and data collection system, but if we share this data, we will have more opportunity to compare data one against another and maybe help with some even illegal activity like illegal waste dump or oil spill, so we can observe it and use this information together, fight with it.
Good. Sylvain, any final comments to this topic?
Yes, clearly. I think we should all realize that space plays a critical role in climate change monitoring. Of the 50 or so essential climate variables, 50% of those 50 can only be collected from space. So we have the potential to provide humankind with a tremendous amount of information, because these 50 essential climate variables provide the report card for the health of our planet. And I'm very happy to say that in Canada, we've been concentrating a lot on collecting data for climate change science and analysis. And we were actually providing 11 of the 50 ECVs to our scientists. And furthermore, in Canada, climate change, and probably in most of your countries, climate change is a whole of government approach. And I'm very glad to see the kind of dynamic that takes place when you match people from the space agencies and have them rub shoulders, rub elbows with climatologists and environmental scientists. The combination of that knowledge and that skill is going to yield some fantastic results in the future. With respect to the downstream, Canada has an open data policy, so we are looking at putting all of the science data that we collect onto an open form, which will allow a richness of information for the downstream software applications. But further than that, because of commercial space, we are already seeing some great new innovative models taking place with respect to monitoring the climate as we go forward. For example, in Canada, we have a small company, an SME, called GHG-SAT, so GHG for greenhouse gas emissions. And it's a company that we've supported from an R&D perspective throughout the years, and they're now quite successful in selling the GHG data to their customers here on Earth. They're launching a new satellite, and they've actually offered back to the Canadian government and ESA 5% of their capacity for science. So here's a commercial enterprise coming back to government and giving us some of the richness of their data so that we can provide the necessary scientific analysis that comes with climate change.
Wonderful, thank you. So we have about 20 minutes, a little bit more than 20 minutes left, and we are coming to the question of the audience. And I don't know if they can be blended in. That's also very nice, this drawing. But yeah, so you can see some of them. I see much more on the screen, and we will select some of them. We will not be able in this short time to answer all of them, but I want to answer the first question, which was heavily, and this is an exception this year. The question is, I miss an important space agency in this panel, where is China? And we just want to say that this is actually a time conflict, why the representatives of China are not here. But there are many Chinese participants here at the IAC. You know, there are more than 6,000 people, and many Chinese participants are in the technical sessions. So this will compensate for this one panel where unfortunately to the time conflict nobody could be present. I want to continue with the questions, because I see many more questions than you see, which came always again. And this is probably a question to Jim. Will there be other astronauts than Americans, so Europeans or worldwide astronauts in the Artemis program?
Absolutely, absolutely. We want to see astronauts on the surface of the moon from all the nations, and that's the goal. And certainly, you know, as we move forward, we're going to need as much international support as possible. And I would imagine that as we go through the negotiating process for which countries are going to be participating at what levels and what levels of contributions, there is no doubt going to be international astronauts on the surface of the moon with our astronauts on the moon. So that's the vision. We want to be side by side on the moon with all of our international partners currently with us on the International Space Station, and of course we want to even expand it from there. So I think there's a lot of opportunity for all of us.
Good. Thank you. I have a very interesting question for Sylvain. There is a federal election in Canada today. If a new government takes over, will they continue the space strategy or change it eventually? Sorry, but
You had to pick that one.
we have to have, the session is called Challenges and Opportunities in a Changing Environment. So, we have to make it lively, It's after lunch, so.
Yeah. But my spidey senses are tingling, and I'm certainly going to be quite careful with how I answer this, because no government official wants to be quoted in the media on election day. But joking aside, though, this is a rather easy question to answer, because through successive governments in Canada, and we've also seen it in other countries, particularly in the US as well. You know, space is one of those compelling industries, one of those compelling areas of a society which translates to a lot of support. So, you know, I'm going to be very hopeful and very diplomatic to say that I think regardless of how the elections turn out, and we won't find out till about 10 o'clock tonight, we are looking at getting support from all of the parties that will be elected.
Do you allow me to react on that?
Absolutely. You know,
So
it has to be lively.
I just want to give you a little bit of hope, Silva. You have in ESA we have 22 member states plus Canada plus Slovenia, and if you divide 22 just by 4 years of normal political term, you have at least 5 elections per year. So therefore, I can tell you, and we have even some now before the ministerial. So for us, it's a normal day to have elections and strategy of space. So it will work, I'm sure.
Well, thank you. I feel a lot better.
So I'm just looking. There are so many questions, and I see many more than you do. And I just try also first. There are specific questions to each of you, and I would like to address them. But of course, there are also questions which address all of them, and I'm just trying to find. I think. There's one question which is also interesting, which says, since the gateway will require an international agreement, why not extending it also to cover, it is actually jumping, so I cannot see that anymore. Yeah, why not extending it also to cover lunar surface operations and create a complete legal regime? So this is a question, I think, which comes very often. We have also a community of space lawyers here, and this is always a very important community with a moot court at the IAF. Is there anybody who would like to ask the question? You see it, it's the blue one in front of you.
For me, it's very simple. We have this IGA for the space station, and I heard that it took about 8 years to formulate this. So if we start now a new IGA for the gateway or for the surface of the moon, we have to wait 8 years. And I don't want to wait 8 years. And therefore, I believe we should try whatever we can that this IGA of the ISS is used as an umbrella. And underneath, we are writing some MOUs, and this can cover then the individual things. By the way, we also have to make sure that we have at least the same number of international participants as we had in the past, and not starting from scratch and having new political discussions on that matter. So I would like to see, take it what we have and try to go on with MOUs, etc., and not writing a new IGA. I don't know whether you agree, Jim.
I completely agree. I couldn't have said it better myself. IGA is Intergovernmental Agreement. It goes back to the International Space Station. And the key is, how do we take that agreement and extend it forward to the moon? And the way we do that, I think, is going to enable all of us to go faster and achieve milestones and capture the imagination of the public. And I think those are all things that we have to do. I do agree that extending the IGA is the quickest way to make it happen. And how far can it be extended before it starts breaking apart? Here's the thing. It's an intergovernmental agreement, so as long as we all agree, we can keep moving forward. So I'm hopeful that we can use it and make it a good run. So.
Any other comment? And if not, I would like to ask Sergei, what is the likelihood?
Sylvain wants to react on that.
Sorry,
I wanted to add to that. The way I'm looking at it, I hope the IGA will be the mechanism to go forward. But I also hope that we hit a point of discovery at some point where we decide that just like we're going to push the boundaries for humans and technology and medicine and everything else, I think this new venture that we're engaging in is hopefully going to get us into new conversations, into new areas of law, new areas of how humankind sort of regulates itself as we go forward. So I'm seeing this space law, and particularly any moon law that we may have to develop at some point, as a discovery, as much as we need to discover everything else that we're going to have to go through as we go forward. So I'm actually looking forward to areas where we'll be breaking new ground in this area. I think those are going to be very, very groundbreaking and interesting conversations to have.
Good. I have a question to Sergei. What is the likelihood that we will see Russia partnering on the gateway?
Yeah,
Sergey.
we are planning to participate in Gateway. We don't have a final decision how and which way, but for sure, what we said before, that international cooperation is important. It's important for Russia to stay together with our partners, and of course, we will develop our own national program. And the problem now is that this program need to be adjusted to each other. So we need to clarify what we are going to do with Russian program and see how this program will be joined together with Gateway program. But for sure, as I said, international cooperation is very important for us, and we see even before ISS, we start to do our international partnership even earlier. In human space flight, we started from Apollo-Soyuz project, and we continued through Mir shuttle project. We work together on Mir, and we have very good experience of working together on ISS. So for sure, we will continue together, but which way we need to clarify a little further down. And talking about agreements, what I would like to add that every agreement is not fixed subject. When conditions changed, of course, we need to sit and negotiate, and maybe something will change. As we had our agreement about Moon and other celestial body in 1974, if I'm not mistaken. But of course, time changed and conditions changed, and we need to sit together and maybe make something more specific. And probably the same will happen in the future.
I have two more questions to JAXA and to ISRO, and then I have really a funny question which you don't see here to finalize it. The question to JAXA is, how will JAXA use their asteroid mission experience to support the development of technologies to utilize asteroid resources like water for in-space purposes?
Well, I think the two Hybris missions already, became the foundation, has laid the foundation for at least finding resources, the asteroid, and collecting samples from the asteroid. And the current application of Hybris is not the third asteroid mission, but the next Martian moon mission. So we will go to one of the Martian moon, Phobos or Deimos, and actually Phobos or Deimos looks like an asteroid, so that we can apply Hybris technology for discovering, getting a sample back to the Earth. And talking about the applicable technologies directly to the surface of the asteroid, again, I think we will have to consult with private sectors, because we would like to make it, next phase, we would like to invite other players, especially the industries, to make it a more viable mission. So that's the current situation.
Thank you. And for ISRO, for Mr. Somernath, is a question: how soon can we expect to see private launch vehicle companies operating in India? These are all these challenging questions today, you know.
I believe it is very soon. We are trying from ISRO side itself to promote this idea of private enterprises taking over the launcher activity. This is already on for PSLV, as I already mentioned. And there is a lot of discussion going on with industries to take it on a step-by-step process. But when we looked at the small launcher, we want to take it from the day go. hand over the whole design and the whole authority of processing the launcher from them itself. And I am really more excited about not this activity that ISRO does. It is more on the private side as well. There is a lot of activity going on in designing rockets, designing engines, and configuring small launchers, activities spread across our educational institutions and IITs. It's really inspiring to see them investing, and private companies are coming forward to put their share into it. There is a lot of activity going on. I believe either one of these will definitely take place, one which is spurred by the activity of ISRO, the one which is happening 100% in the private sector. One of them will mature into a private launcher, we'll definitely see in a few years from now.
Yeah, and this is, I really want to thank the audience because it's amazing. You see only a few of them. I scroll up and down, and so this is really a very nice interactive tool. And thank you very much for your questions. We cannot take all of them. They are all valuable, and I'm sure we will collect them.
I would like to answer the one about Greta.
Yeah, but I have a much more, I have another one, which is really, but I think this is, I think we can do that, but I want to go to this one question. When will we finally arrive on Mars?
Wednesday. Wednesday. Monday is moon, Tuesday we don't know, Wednesday is Mars.
So if we accelerate the moon landing, we are accelerating the Mars landing. That's what we're doing. And I would argue that, look, if our budgets were sufficient, which is going to require a lot of us on this stage to work with our governments, I would suggest that we could do it by 2035.
Any other comments? Any other comments to this topic? And then we will, Jan, you want to answer the question. How would you justify the costs of your programs to young climate change activists like Greta? I think this is a really very easy answer. But,
So there are several answers to this question. First of all, climate change was discovered by exploration. This is an important message also for the young people, because climate change was not discovered just by keeping the thermometer out of the window, but climate change was discovered on Venus, because Venus has a dramatic greenhouse effect. So this shows already that climate change as it is something which has a direct link to exploration, which I'm quite sure Greta would not think about. But the other thing is concerning the costs. We ask the European citizens, what about the costs of space activities? And the guess was something like 260 euros per year and citizen. 260 euros per year and citizen. This would some amount of money. I'm quite sure with climate change we have to spend more. But in fact, all what we are doing in exploration is just 2 euros per citizen and year. And therefore it's rather cheap, low amount. And by that low amount we find so much things about us concerning, for instance, also climate change. And in addition, we are doing climate observation and climate change observation with space. So space is helping Greta. And therefore, when we had our last big symposium, Living Planet, it is called in Europe, we invited these organizations, Fridays for Future, and they gave also a presentation over there. And it is clear this is not somebody who is fighting against space or something like that. We are joining forces because both is for humankind and for this really very nice blue dot in the universe.
Yes.
I would like to double down on something Jan said earlier. He talked about technology specifically. Look at what's happening with the automobile industry. We are seeing a lot more advancements in technology, whether it's automation, in other words, self-driving cars with electric engines and ride sharing. Those three things combined are going to transform how we travel terrestrial, not just in the United States, but all around the world, and have significant reductions in greenhouse gas emissions. Now, all of that is made possible by satellites, whether you're talking about GPS for navigation or whether you're talking about using the timing signal from GPS for terrestrial wireless networks that enable your cell phone to ultimately be a networked computer in your pocket. And GPS is just one element. We talk about the future with Galileo and GLONASS and BeiDou and all of these other systems that nations around the world are building. These are going to be transformational capabilities that benefit us when it comes to greenhouse gas emissions. I would also argue that if we look at what's happening within the aviation sector, it is not too much different than what we're seeing on the terrestrial transportation sector. We're talking about more automation. In other words, right now, NASA is working to integrate unmanned aerial systems into the national airspace system, and we're doing it with automation, which, as Jan mentioned earlier, enables us to more efficiently travel across not just countries, but across the world and saving the amount we spend on fuel. But also, we're investing in more electric architectures, electric engines, of course, automation, and ride sharing as well.
And don't forget the solar cells, and the efficiency of solar cells comes from space. And fuel cell, Apollo was driven by a fuel cell, so this is also technology which help us to reduce the climate impact. So there's a lot of technologies.
Look, I don't know, if we are worried about greenhouse gas emissions, how can you not explore space? That's the question.
Good.
Okay, so thank you for this very inspiring answers. Now we have to conclude, but I would like to ask to each of you just a quick question. Next year, the IAF will celebrate its 70th anniversary, and in 1 minute, could you tell us what the IAF does bring to your organization and the space sector? I will ask by Sylvain. Sylvain.
Well, two things, I guess. Other than the fact that we're bringing in a community of passionate experts every year to these international venues, we also bring leadership from the various space agencies and heads of industries across the world. And at this conference, I found over the last few years that the meetings that we're able to entertain because we are here physically in person have been absolutely key to international collaboration going forward. So there's a big education and learning aspect to this conference, but the international collaboration and the deals that are struck here are absolutely fantastic. And the second thing I'd like to say, just very quickly, the fact that the conference moves to different places in different cities on an annual basis also allows for local communities who may not have the opportunity to travel to actually participate when the IAC is in their city and actually get exposed to space and to the fantastic things that we do here. So that aspect of it, I think, is also very important.
Okay, thank you, Sylvain. Mr. Somanat, what does bring the IAF to ISRO?
IAF is a wonderful forum for cooperation and exchange of ideas. For a country like India, it was a big gap once existed between the people who were having capability to go to space from a country which is just aspiring to become a launch or a space faring country. And we had a gap of almost 50 years. And this gap could be brought down substantially in the last 50 years with the help and cooperation and the knowledge exchange and the understanding that exists across various spacefaring countries. And I must acknowledge this particular aspect of the international cooperation to enable people like us to come up and handle this complex task. And IAF stands as a forum for us to collaborate, to understand each other, and to work for a common cause, to say that we are one. Thank you.
Okay, thank you. Hiroshi, IAF for JAXA.
Well, yes. Well, I think the IAC is well, everyone knows that the IAC is the biggest in historical networking opportunity, and I think that's why various players gather from all over the world, including experts, politicians, and young professionals, and also students. And I would like to express my deep appreciation and respect for the continuous provision of this kind of precious opportunity for for about 70 years. And I think, well, everything has already been said by them, and I think by my friends, so I will not say the same thing, but I'm sure that the JAXA will continue to support the IF activities.
Okay, thank you. Jan?
I ask me that question each and every year, I can tell you. And my
We will see if it is the same answer.
You're
as
part
last
of
year.
it, yeah. You're vice president.
my reaction is, first of all, exchange of people, to meet people, a lot of people from around the world. This is number one for me. That's the most important part for me for the IAC. The second one is proof of ideas. Here you can mention ideas in the presentation and you can see what the reaction is. And then you can take it home and further develop or kick it off. Third one is proof of communication. So we did it right now. We were discussing about how to communicate something, for instance, about Greta. And this you can take home and you can communicate it also to the outer world, outside the converted ones. And number 4 is looking also for cooperation, very concretely meeting people, discussing it. Where can we work together, as we are always doing with many of you as well. So this is.
Okay, thank you, Jan. Sergei?
For me personally, this is a very good place to meet my old friends, because being in this system for a long time, on this kind of conferences, I have chance to see someone who I haven't seen since previous conference. And that's my personal feeling. But for the system, I think what is most important is exchange. What we said, exchange ideas between different agencies, between different programs, and exchange also ideas with generations. I think IF is doing very great thing, attracting new generation to this kind of conference, and people who are already in this system for a long time can share their experience and attract new participants for the future.
Okay, thank you. And last but not least, Jim?
So I would say getting everybody together in one spot to have these discussions. Of course, we have them here on stage, but we also have dialogues one-on-one. We have dialogues in groups, and getting us all on the same sheet. So as we go forward together. Again, all of us can achieve more when we work together. And this is one of the rare occasions when all of us are together in one spot and we can collaborate to really advance the condition of humans. We want to go further into space and go further than ever before, and this is the forum in which we can agree on how to do that.
Okay, thank you. So, Pascal, I think that you have your roadmap defined by the head of Space Agency.
I have to make a 2-minute summary because I know that the technical sessions are starting, and I stood up so that I'm not in the back to this part of the audience. I really want to conclude very, very fast. I think that concerning exploration, all the presentations have shown really exciting new missions and program. There is I think a new momentum, and that also engages international and commercial partnerships. And I have made some notes from Jim Bridenstine. Artemis is actually a generation. It stands for sustainability. It is an open architecture and invites also really international cooperation and obviously also commercial actors. So this is, I think, a very, very good future motive where a lot of people will able to join. Probably it will be difficult for you to leave this room, and a lot of people will come to you. And obviously there are many important missions in this, also on the national scale, but hardly any is without international participation, and hardly any of those missions is actually without commercial participation. So there is a change. There's a paradigm shift in the space sector with, I think, really unprecedented entrepreneurial leadership and private investment, and we are really advancing space technology and the future of exploration. And concerning the climate change, I think one of the main goals was sharing the data, and I think we have discussed that in many meetings, also in the United Nations meeting, IFUN meeting on the weekend already. It is important that all these products, if they actually actually elaborated by the downstream sector, that they actually arrive there at the community which really needs them. And this is something which we have to ensure in the future. And I want to thank everybody for the positive feedback to the Federation. The Federation has really developed in the world's leading space advocacy body with almost now 400 member organizations across 70 countries, and including everybody, space agencies, industry, societies, universities, associations, and institutes worldwide. And we are really open. The feedback was different, but we are really open to a renewed impetus and innovative measures responding to the challenges of a globalized world. And I want to ask you kindly to help me to thank all the heads of space agencies which have participated to this panel, and I hope you had got the information you need. We cannot address all topics, but we try to address the real main topics, and I think the interaction with the audience is always improving and makes fun. Thank you very much.